Okay, so let us quickly solve this Olympiad math problem. Okay, welcome back to my channel. If today is the first day of seeing my video, please like this video and comment and follow us by subscribing. Right, this is very simple. The first thing you do is you try to make the power to look like the base. Okay, so simply take the log of both sides in base 3, since this one has base 3. So I'm going to say that this is log x raised to power log x base 3, okay, in base 3 is equal to what? Log base 3 of 81 x raised to power 3. Now the next thing you need to know is, according to the law of logarithm, if I have log m raised to power n, now the n can go to the back, you have n log m. Okay, so this log x base 3 can come to the back. I'll have log x base 3 log x base 3. This one went to the back to multiply this one, is equal to what? Log 81 base 3 plus log x raised to power 3 base 3. According to the law of logarithm, the reason we have plus is because of multiplication. So you can separate them to be like this. All right. So now, this could be written as log x base 3 all squared. Okay. When something multiply itself, it can be written like this, is equal to, now this is log 3 raised to power 4 base 3, then plus the 3 can come to the back to become 3 log x base 3. All right, so now this is now log x base 3 all squared is equal to 4 log x base, sorry, 4 log 3 base 3 plus 3 log x base 3. All right, now this is very simple. When the log and the base are the same thing, the answer is just 1. So what do? So this is now log x base 3 all squared is equal to 4. 4 times 1 is 4, okay? 4 plus 3 log x base 3. Now, we can say let log x base 3 be equal to y. So anywhere we see log x base 3, we can simply put y. So this is what? Y squared is equal to 4 plus 3y. Okay, let's bring everybody to the other side. I'll be having y squared minus 3y minus 4 is equal to 0. So this is factorizable. It's a quadratic equation and it is factorizable. So I'll be having y squared minus 4y plus y minus 4 is equal to 0. So I'm having that y into y minus 4, y minus 4 here. Then I'm having plus 1 here is equal to 0. So what do we have? What is common is y minus 4, and the only remaining thing will become y plus 1 is equal to 0. And when the product of two things is 0, automatically one of them must be 0. So I'll be saying that y minus 4 is 0, or we have that y plus 1 is 0. So what do we have? That y is equal to 4, or y is equal to what? Minus 1. But obviously we are not looking for y, we are looking for x. So for us to find x is very simple. We'll tell them that they should recall, but they should recall that there is a place we said, that log x base 3 is equal to y. So if we take when y is 4, we'll be having log x base 3 is equal to 4, or log x base 3 is equal to this one minus 1. Now, according to logarithm, if this carry this as its power, the log will disappear. So I'll be having 3 raised to power 4 will be equal to what? This x. The log will disappear. The same thing here. This will carry this. So I'll be having 3 raised to power minus 1 is equal to x. The log has disappeared. So what we have? X is equal to 81. 3 raised to power 4 is 81. Or x is equal to what? 1 over 3. Okay? So that is that for that. Let us check if it is correct. Let us cross check if it is correct. So let us check. The first one we got was check. The first one we got was when that x is equal to 81. So if x is equal to 81, let us see if the left hand side will give us the right hand side. So I'll be having 81 log 81 raised to power. So I have 81 raised to power log 81 base 3 is equal to 81 into 81 raised to power 3. Okay, so what do we have? this could be written as 81 raised to power log 3 raised to power 4 base 3, okay, is equal to 81 raised to power 1 multiplied by 81 raised to power 3, okay. Anything raised to power 1 is still the same thing. So, like I told you before, this 4 can come to the back. So, I'll be having 81 raised to power 4 log 3 base 3 is equal to 81 raised to power 1 plus 3, okay. Now, I told you that if the log and the base is the same thing, that the answer is 1. So 4 times 1 is 4. I'm left with 81 raised to power 4 is equal to 1 plus this is still 81 raised to power 4. You see, the left hand side is equal to the right hand side. So x is equal to 81 is correct. So let us check for x is equal to 1 over 3 and see what we are going to have. Okay. So when x is equal to 1 over 3, when x is 1 over 3, we'll be having that 1 over 3 all raised to power log 1 over 3 base 3 is equal to 81 into 1 over 3 raised to power 3. Okay. So now this is going to be 1 over 3 into, this is going to be minus, sorry, it's going to be log 3 raised to power minus 1. Okay. Yes, 3 raised to power minus 1 base 3. Because according to indices, if you want to remove 1 over, the power is going to be negative. So is equal to 81 into 1 over 27. Okay? Because 3 raised to power this is 27. So I'm going to have that this is 1 over 3 into, according to indices, this can come to the back. I have minus 1 log 3 base 3. Okay? Is equal to this into this is giving me just 3. Okay? It's giving me just 3. Now, if the log and the base are the same thing, the answer is 1. Okay? So minus 1 times this is giving me minus 1. So I have 1 over 3 raised to power minus 1 is equal to what? 3. Okay? Like I told you before, if you want to swap this thing, now the power is going to be negative. So this is 3 raised to power minus 1 for the one inside. Then multiply by another minus 1 is equal to this 3. This time this is giving me minus is plus. So we're having that 3 is equal to 3. So the left hand side is equal to the right hand side. So therefore, x is equal to 1 over 3 is part of the solution. So thank you very much for watching. Please don't forget to like this video and comment. Tell us what you think. Bye-bye.